The topic is SAP on hyperscalers. Okay, so we're going to discuss what are these hyperscalers and why it is so significant for us to understand the concepts of hyperscalers, and what is the advantage of being on hyperscalers, and what are the disadvantages. Okay, so let's see agenda. So introduction to hyperscalers. I mean, what are the, as I said, we will discuss who are the players in the market now, and what are their architectures. So SAP on hyperscalers, and why SAP is moving towards hyperscalers these days, and what is the strategy, to migrate to the hyperscalers. And there are part one and part two. Sorry, I correct it later. Architecture on hyperscalers, and what will be the architecture, how it will be different from existing SAP business suite architecture or infrastructure basically. So, and as I said, security, one of the most important thing, security design, and what are the monitoring considerations when you move it to the cloud. Okay, deployment considerations, runtime considerations. When I say in this entire discussion, right? Whenever I call it as an hyperscaler, so hyperscalers are nothing but cloud infrastructure providers. Okay, that is the synonym or the technology term which we use, hyperscalers, because we cannot always pronounce it like AWS, Google Cloud or Azure or Alibaba Cloud like that. So it's difficult. So what we do is I will call it as an hyperscaler. So wherever you see the word hyperscaler, which means any one of the cloud infrastructure providers. Okay, so it could be anyone, whoever is in the market. We will discuss what all the cloud infrastructure offerings available in the market. Okay, so good. So let's start now. The introduction to hyperscalers. The first question: why we need hyperscalers? I mean, why we need this cloud infrastructure? Okay, so I mean, why it is so significant now? Not, I mean, earlier it was not the case, right? So why is the cloud infrastructure is very, very, not many customers are moving. Okay, so I mean, so many, Nestle has moved to Microsoft Azure, and then BP has moved to AWS, British Petroleum, and then Unilever is moving to, now they're planning to Google Cloud Platform. So there are many companies or the many customers now they are going to the cloud infrastructure or the hyperscalers. Okay, well, in 2000, yes, SAP introduced HANA in 2011. Okay, so but the hyperscaler movements, but from then onwards, AWS was there. So AWS was the cloud infrastructure provider which has entered into the market. But AWS was the only one, who has aimed or at SAP. So if we bring SAP to hyperscalers, they thought that they're going to have a huge market, right? So what AWS have done, 2015 onwards, 2015 to 2020, AWS was the leader when it comes to the cloud infrastructure or the provider for any. So AWS was successfully able to capture the market, and they have moved a lot of SAP customers to the AWS cloud. Okay, slowly Google came, and then Google also started taking over some customers. But Azure was late, but it is very fast in terms of the adoption. Yes, it was late. Last 2 years only Azure was came into picture, but it is very fast in terms of the adoption. I mean, customers are implementing, moving their SAP applications to the Azure infrastructure so quickly. I mean, very, very in an aggressive way from last 1 year. Okay, now AWS and Azure are the top competitors when it comes to the SAP's cloud infrastructure providers. Okay, so before I will go and tell you about these cloud infrastructure, and we discuss about all these things, I want you to give you some basic understanding of what are these on-premise infrastructure. Have you heard of it? On-premise. So I think all of your solutions. So in your projects, where your applications are hosted SAP systems, on-premise or cloud?
On cloud, our project.
Oh, your project is on cloud. Which cloud provider?
Azure.
Azure. Okay. Good. Anybody still using on-premise?
We are using on-premise.
Good. Okay.
Yeah, ours is on-premise only.
So still majority of the customers, yes, the adoption is faster, but doesn't mean that all customers have moved to the cloud. Okay. So still they are skeptical in terms of the data and stuff. And some companies have, some countries, not companies, countries have some rules and regulations. Okay. I will explain when it comes to the security, what are those rules and regulations and policies for that particular region or the countries. Okay. So first thing is, so our traditional way of hosting systems earlier, even now, was the data centers. Okay. So you might have heard the word data center. So data center is nothing but where they will host all these servers. Okay. Physically, the servers or the network or everything is available. So for Europe, in Europe, there will be data center, and America, there are data centers. And in India also, we have some data centers. Recently, Reliance has launched it. So many countries, why do they choose Europe and America? Can anybody tell me? Yeah, there are reasons. They don't want to get the data, and those are different things. So Iceland is the most, which contains the majority of the data centers. Can you tell me the reason? Iceland. So what is the coldest country in the world? Okay, coldest country. So human living, Antarctica is there, but coldest country, who will be the where some human population is there? Iceland. Okay, Iceland or the Finland and those countries have the cold countries. So why these guys? Whoever is setting up the data center, why do they choose these countries? Is because the cooling of the data center.
No, the maintenance might be lower.
Maintenance is lower.
Like the
cooling.
Yeah.
Yes. So the server.
Cooling part.
Yes, the servers get heated up, right? When you put even your machine laptop, you keep running it, it gets heated. Your phone also, you start using YouTube for 1 hour, it start heating. Then imagine your servers are handling a data of 2 TB or 3 TB of data. That is just for one application. So your data center might be like some 100 acres or 200 acres of land. And in that, you will have a huge number of servers. The cooling, you have to spend crores of rupees for cooling only. Okay, crores and crores for a day. So if you put it in a cold countries like Iceland, so the cooling will be automatically taken over. That is why the APJ region countries, for example, India or the Singapore, Philippines, Singapore, there are data centers, but because for latency considerations, but they had to set it different regions, but for that purpose. But if you look at it, majority of these data centers are in the cold countries. So Europe is a cold region, so they try to put majority over there. America also, where Canada, wherever there is a cold, and to again, it is important to put it in the less populated areas. If something happens, some blast or something, or some terrorist attack, also people should not get affected. So that is why they choose the locations where the human population is less, and they also choose the countries where there is too much of cooling. So that they can save lots and lot of money in terms of the data center maintenance. Okay, fine. So that is what is called the data center, which is available in the anywhere. So the traditional data center, sometimes sea also they put in ocean. So recently Microsoft, you Google it later. So Microsoft's data center in the sea, how they are maintaining and how they are doing it. So in direct water, so that they can save even more money. In terms of the cooling. Okay, so fine. They host the data center. The traditional on-premise data centers are, for example, majority of European systems there is a guideline in Europe. Okay, they have to host the data center within the Europe only. Okay, that is the European policy. Okay, they don't want to put their data centers anywhere. So you have to put, that is the policy for that European region. So whichever your business is operating, so you should have the data center within the Europe. You have Frankfurt, Waldorf, SAP has some data centers over there. So I visited a couple of data centers. So I've seen how beautiful they are. It's very beautiful in the sense I liked a lot the data centers, the wires, the cables, and it takes 1 week. At least 3 to 4 months before you have to request permission to visit the data center. Okay, because at least it takes 1 week for all the approvals and all this stuff, and you need to have a very strong security clearance to get into the data center. Okay, because you just enter, and if you pull out some plug, right, that's it. So you don't know. So day in and day out also the data center, the engineer doesn't enter. So that's why I think you might have heard issues, data center issues. So then you have to wait 24 hours. The engineer has to go and then fix that one, right? So it is very, very secure, highly secured, and it is not easy to get the access. So once you have, and they will send you with the completely trained person. Fully aware of the data center, and he will acknowledge, and they will give you gear and all. Because inside it will be little warm. It is not just a thing. So you have to go in the shoots, and then you see the data center. It took me around 2.5 hours just walk in the data center, continuously without stopping anywhere. Just walking in the data center took me 2.5 hours, where I was able to see the servers, where I was able to see the networks, cables. So I was like crazy. If you see the data center, oh God, you don't believe it. It is such a messy, and messy in the sense, so many cables, so wires, you don't know which one is going what, and then there will be labels on each wire, coloring. So you find hundreds of colors of wires. You take WebGR and these combinations, you imagine. So there will be stickerings on each cable. So if you have to fix, you have to hold that cable literally, and you have to walk with that cable. Hold it hand to hand. You walk around at least 1 kilometer in the data center itself. Suppose if you want to understand what has been caused. So these are the data centers which are available for the customers. Customers used to own their own data centers. Okay. So if you take Unilever, they have their own data center. So Nestle, they have their own data center. So BP, they have their own data center, which means their applications runs, servers, everything is hosted over there. So those data centers were taken care by the earlier HP or IBM, Fujitsu. These are the top players when it comes to server provisioning or the infrastructure provisioning at that time. And Windows machines, and there are VMwares and all there. On top of it, there is a technology. But these were the top players when it comes to the server provisionings. So, but the biggest problem with the owning a data center is very, very high cost. So, you have to own a data center, maintenance, support, cables, and all these things are very, very problematic for them. Okay. And then, so if you want to scale up or scale out, so scale out also, your data center will have a limitation. Okay. So the data, you get too much of data and your organization grows and you have to expand, right? Scale out. So initially you would have thought that, okay, my data center will be sufficient for next 10 years. But unfortunately, with the revolution in the IT industry, the data has grown significantly. So every customer, whoever has guessed, right, okay, next 10 years, my data will be 5 TB. No, all their calculations has gone wrong. Okay. So that 5 TB had become 10 TB, 20 TB. Okay, so now you have to expand your data center. So expansion of the data center is not easy. Okay, there is a limitation also, the racks. So yes, scale out, you may say that I can go with scale out option. Fine, you go with scale out option, but in the data center, you should have racks to put the servers, right? You should have a space. Each server needs, some thousands of cables, thousands of RAMs, CPUs, and you have to insert them in the rack. You heard the rack, right? Like shoe racks or our cloth racks, there will be racks. So in those racks, you have to fit them. Those should be available. Getting infrastructure hardware is fine. From Fujitsu or HP or somebody you can put, but you have to plug it in the data center in a rack. Okay, that is not easy. You will not be having space. So with the tremendous growth, so expansion of the data centers is very, very difficult, or they have to host again a new data center. Then again the problem is, so existing data center and the new data center, there will be some gap or the distance. Again, you have to connect them with pipes or the cables, like water pipelines you do. You have to connect them to the cables, and then again you have to put the uh, what do you call network bandwidth latency issues if they are in a different data center. So there are a lot of problems, and moreover, from this data center to other data center, you have to connect through cables, right? I mean, if you put some new one, so that government permissions, local authorities, they may not accept it. See, for simple road extension only, we are taking a lot of time to clearance, right? Government has to clearance with the, people should be ready to give the land. Okay, if you want to expand your road, if it is a private property. So same there. So it is not easy to get the land. I mean, to put these cables and all this stuff, because people who doesn't know about IT, so you, even though you say that it is not environmental issue or it is something good, but people don't agree because you are digging in the ground. I mean, you are putting such a heavy cables. Who knows? So these are the very, very problematic situations, in the data centers, and repairing also very difficult. Okay, and moreover, the customer has to take care of it. Each customer, it is he or he has to put third-party vendor, HP or IBM or this thing. So these third-party vendors also all like their support is also optimal, or we would say not so good, because they knew that nobody in the world are offering these data centers. So why can't we simply they have their own SLAs and they don't support. So this is a very, very problematic situations for the customers. Okay, so whenever there is a problem in the data center, means it's a very hectic and very irritating thing for the customers. Okay, so they have to push people, go do that, and very few people can go there. So it's all messy. Okay, but yes, on-prem still we are using, because because what do you do once you build a house? You have to live in it, right? So, I mean, this is what. So, majority of the customers have already invested in the data center. So, those data centers are catering their services, right? I mean, they're up and running. So, maybe once their what we call their data increases, and once they have to go, I mean, exponentially they grow. So, they may think of migrating, but many customers still on-premise. But the future is definitely the hyperscalers, cloud. Okay, so fine. I have explained you the current data center problems. Okay, I mean, if you think of anything else, please let me know. I mean, if you come to mind, but as of now, I can think of only these two. So, how these hyperscalers solve these problems? Okay, so innovation. So, as I said, until 2011, we were all using this Oracle database, disk-based database like Sybase. Okay, then DB2 was there. All are this disk-based. So everything is written in the disk, and all calculations, all things happens so there. But 2011, SAP came up with HANA, right? So which means why SAP could able to come up with HANA? Yes, software innovation is one aspect. When I was explaining HANA, I told you. So in-memory computing, okay, they came up with because they guess the trend or the market, the infrastructure innovations nicely, and then they thought infrastructure costs are going to be down because infrastructure development or the innovation happened. Believe me, in the last 10 years, it is one of the most, invested technology infrastructure. When I say infrastructure, it is a data center or the servers. It is the one of the highly invested area. We may think that Tesla, we may think NASA, they're investing in all these things. But believe me, infrastructure innovations were the highly invested in the world. So crores and crores of dollars of money has been invested in these infrastructure innovations. Okay, so you see how many things came out of that innovation. You look at it now. I mean, maybe you may not appreciate it at the moment because you are just starting your careers. You will appreciate it after 4 years. I mean, you work on your on-premise systems now. After 2 or 3 years, when you start working on these hyperscalers, you realize it what kind of innovations they have done. It is highly effective. We will talk about them. So they are like they're fast. I mean, the servers are too fast. I mean, like a HANA, high RAM, high CPUs, and then scale out became much easier. I mean, you can put any number of servers, And they completely avoided the limitation of this data center. I mean, dependency on the space and servers and all these things, because they are like infinite kind of model. You keep on increasing. That's it. So they would have, see, it is like this. So you procure our land. So or they procure not land, they procure entire country. I'm saying in Iceland, if you take, there is so much of space. So they will take some one country, one like Bangalore kind of city, they will take it out completely. One guy, AWS, which will purchase it completely, and then Microsoft will do it some different location in Frankfurt or something. So they take the entire place. Okay. So I mean that place is only dedicated for those guys, and government is also low. They keep doing data centers only over there, nothing else. So then infinite kind of models. Okay. And moreover, because there is like increasing the servers or the scale out is much simpler. I mean, in a fraction of seconds, it can go there. And moreover, the entire infrastructure operations, too many innovations, automation, I mean, innovations in terms of deployment has become much quicker, and the security, providing the security groups or authorizations became much simpler, and repairing or the maintenance also much simpler. Every aspect, you name any aspect. So they have done some excellent innovations in terms of the infrastructure. Now what we are using infrastructure as a service. Okay. Earlier, setting up infrastructure was such a horrible, or it's like constructing a house, get the material and everything. Now we have evolved to a situation. If you just want an AWS server, just go to AWS cloud, just put it in Google, log in with your credentials, give your credit card details, just deploy the server, whatever you need. It is as simple as that. It's a service. It is like in mobile you are deploying, So they have brought to that level, but this was not the case 10 years back when we were working on setting up this on-premise. So maybe you were thinking you are working on an on-premise system. So you don't know the pain, what they have felt when they were putting those servers and all. It was like a data center construction. Okay. So first they had to construct customer if they want to move, or either they have to lease from HP or IBM, or they have to build their own data center, or they have to purchase it from somebody else. Okay. So those were the challenges. Now it is all like a service. Fine. We will talk about the hyperscalers' strong advantages, but now know that in 2011 or 2015 onwards, all the companies have invested one of the topmost investments in terms of the infrastructure innovations. So what we have today's infrastructure is much more advanced. Nobody could have thought about it. We evolved to an infrastructure to that level. Okay, we have such a flexible infrastructure right now in the market. Okay, so and the innovation. So hyperscalers native services. So these AWS, Google, and everything. So they have not only set up these infrastructures, and they have not only addressed all the on-premise data centers problems. They have also came up with their own services. So wherever they feel there is a need for an improvement or automation, they have done it completely. We will talk some examples of how powerful these things are when it comes to that. So and then SAP Cloud Platform services on hyperscalers. So fine. So SAP also started developing their business problems or some of the thing. They just started coding on the hyperscalers. But now just keep it aside. We are not talking about SAP Cloud Platform or anything, because these are all development related and stuff. I mean, it's too much for you. So right now, let's keep the discussion to the infrastructure only. Okay. So because that is important. Rest all is fine. Agility. So ready to run SAP HANA environment. HA, high availability, and disaster recovery by default. Okay, this is again one of the topmost, since we are talking about SAP, high availability. I told you, so if I have to put it in high availability, so earlier, I don't know, do you have high availability in your landscapes? Is anybody working on your high availability in your projects? So that I can take that example. Sorry?
Yeah, we are having the high availability cluster.
Okay, which cluster you are using?
I don't have idea, but the other team will look after that one.
Okay, that's okay. So it's all right. So high availability, which means, for example, your CI or a database, right? Database is your single point of failure. So keep this word. So for what all components we do high availability is, configure is single point of failures. If your database fails, it goes. I mean, the entire system is down. So for that, you need a high availability. And what is the another component? NQ. In a system, you have only NQ, one locking mechanism. So you need an NQ replication server.
Hey, you know, ZaranTech now offers SAP corporate training. That's right. Train your workforce in SAP with our comprehensive program. We offer customized courses, certified trainers, and hands-on labs for both individuals and businesses. Our standout features? Bespoke training, fully configured servers for practice, in-house materials, and a dedicated LMS. Plus, get session recordings and 24/7 support. From functional to technical modules, we have got it all. Choose ZaranTech for SAP training and watch your team excel. Learn, upskill, succeed with ZaranTech.
So where there is a high availability. See, and then message server. Message server also needs a high availability because you have only one. So single point of failures, you need to put it in high availability so that in case of power failure or the server crash or in case of performance issues on server A, all the applications will move to the server B and they will run. Okay, that is the high availability. Okay, disaster recovery. So don't get confused with disaster recovery. Disaster recovery is a different thing. This is what simple, if I have to put it, high availability. So end user doesn't know that his application has moved from the server A to server B. That's it. So end user will be happily working, but you as a basis admin will get alerts that so and so server is not performing or so and so failover happened. There might be alerts you might have seen. Failover has happened from so and so node to so and so node. Okay. So, but you have to work on why the server was not responsive, what was the problem, and then investigate it and bring it up later. Okay. Bring it up and then you ensure that again the cluster mechanism works as expected. Good. So that is the high availability. So that the end users should not feel or should not know what is happening. At the whole objective should be there should not be any business impact. Maybe your customer might agree for 1 or 2 hours of downtime, but customers like Nestle, BP, Unilever, Johnson & Johnson, who have worldwide products, right? Worldwide retail or worldwide outlets, they do not entertain. I mean, even a 1 minute of downtime also. Because it's a reputational impact, or a banking. If you're trying to log into the HDFC bank or ICICI bank, if you try to do a transaction, it says the server is not available. How do you feel? Right? It's a reputational impact. So banking site is not available, so then you look for alternatives and they lose that money. So it's a very, very bad thing. So that is why high availability for most of the customers, productive systems, I mean, dev and test you might not do, but high availability is needed. So like you said, high availability, somebody else is managing. There is a cluster and somebody is doing it. But if you come to the hyperscaler, you don't need any other team. Forget about it. That also as a service they will provide. AWS will give you high availability just like that. I mean, you don't need to invest on any other team or you don't need to invest on any other software. It comes by default as a server. I mean, that concept. When you procure the server, if you tell that I need a high availability and they will charge you accordingly, that's it. It's a service, as a service. So try to understand as a service means you just take it and use it. That's it. So you don't need to support it. You don't need to maintain it. You don't need to do anything on top of it. If there is any problem, AWS will take care of it. AWS will ensure that if your application fails, then it fails over to the other node. See what kind of innovation. It's an excellent innovation. It saves crores of rupees, crores of money to the customers, right? Customer do not have to worry about their data center, do not have to worry about this high availability and all these things. Okay. And then disaster recovery. So disaster recovery, suppose, again, banking, take banking. I'm taking banking as an example because there are lots and lots of banks, but this is applicable for every company. You take BP, Nestle, everybody needs a disaster recovery. Okay. So the reason is, suppose they have a data center in Frankfurt, and if somebody attacked or some terrorist attacked it, right? Or some earthquake, okay? Or flood. In USA, you see these cyclones and these floods, right? Very frequently. So there is a cyclone and your entire data center power supply has been gone. So what do you do? I mean, to recover it or to bring up the data center, sometimes it takes from days to weeks. It depends. Sometimes it can take months also, based on the impact or based on the damage it has caused, right? So it may take months or years also, because you may have to reconstruct the entire data center. So the flood or the earthquake would have spoiled the whole thing. So what do you do? 1 year, imagine banking, your server is not working, then you're gone. So then you need to have an option that is called a disaster recovery. In case of a disaster, in case of any of these such unforeseen issues, what should I do? Okay. So disaster recovery, again, you should not use the same data center, because if the earthquake happened in the same data center, then if you put the next data center also next to it, then both will go. You're getting my point. So in the disaster recovery, the data centers are placed at different locations. So let's say one is in Frankfurt, another one is in the London. Okay. If one is in London, another one is in Dubai, like that. Okay. Disaster recovery. But in general, they may not take longer distances. Again, the latency issues. Cabling and all, it becomes very difficult, network cabling and all. So they may take at least 200 kilometers to 100 to 200 kilometers distance. They will put another data center for addressing this disaster. But nowadays, this AWS and Google, forget about it. So, customer do not even have to worry about it. Okay. So these guys will take care of the disaster recovery also. They will say, okay, fine. If your system is down, if in case my one data center goes down, don't worry. My another data center will take over. So if that data center is also gone, don't worry. We have another. And they have data center across the world. Okay. So they have done outstanding innovations in the infrastructure. It's not the AWS or Google or I don't know who has done it, but everybody invested crores and crores. But infrastructure concepts and automations were the one of the most outstanding innovations what we see in IT in industry so far. Okay. Yeah, you may say that there are some applications somebody has done developed and all, but they are nowhere compared to the kind of innovations they did in the infrastructure. Okay. So automation. So HA and DR, now you understood how easy it is in the cloud. We will talk. Automation, system provisioning. So now if you want to build an SAP system on an on-premise server, first get the server. I'm giving you an overview. Get the server, create the file system, in the same way, and then run an SAP INST tool. Get the software from SAP, put it on the server. Okay. And then you start SAP installation tool. Then you give inputs for, inputs. So this whole thing will take at least 1 week. Okay. Sometimes 3 months also for planning and, hardware. Somebody Linux guy has to do, so many people involved, right? So infrastructure guy has to provide you the server. OS guy has to do a file system creation. And you SAP guy have to get the softwares and put it there and then run the tool. And then post steps, after you building the system, post steps you have to do, right? For example, configuring background jobs, installing licenses, right? Configuring certificates, whatever we did in our training sessions. So these all things you have to configure, right? And will define your dialog work process and all. So there are lots and lots of steps. These will take weeks or months. Okay. So automation, system provisioning. So there is, I don't know if you guys have looked into the, yesterday I told quick start in AWS. So you just select the product and then launch it. In 1 hour, your entire system will be ready. Okay. Your HANA, everything will be ready. Let's take an example. So let's look at this AWS quick start. I'm just giving you so that you can just put it in the Google. Start building now at no cost. Okay. So this one is fine. Go back. Yeah. Quick starts Amazon Web Services. I'm just taking, but everybody has done this. For example, SAP HANA. That's it. You select this. There is an option to deploy. There is a guide. You see, using AWS SAP HANA Quick Start, we only need to push a few buttons. That's it. I have deployed it. Within 1 or 2 hours, your system is ready. Okay. You can check this later, but you should have this one. You mean the level of automation? Can you imagine? So there are multiple engineers, multiple people who are needed to do this job earlier. Now, with just one guy, even a customer can build it. Okay, you don't need basis guy, or you don't need server management. You don't need infrastructure guy. Nobody you need. You just go ahead and click next, That's it. It's as simple as your operating system, what you are operating. So that is the level of automation they have achieved. Okay. So this is one example. So deploying a HANA system within 1 hour is not an easy task, guys. So, I mean, you see, once they did it, I mean, once they developed it, but because, see, writing the code is one part, but your infrastructure also should let you do that, right? I told you, infrastructure is the most key player here. That innovation, the methodology or the concepts they have used, outstanding. I mean, it will let you automate anything, basically. 1 hour, your system is ready. So you just log in and the end user directly can log in. I mean, you have removed the total number of support people and everybody. Okay. And auto scaling. So this is again, I told you example, data center with the traditional on-premise, increasing the size of the data center is a problem. Here, auto scaling. For example, you have the same server. I mean, you are using a 1 TB of RAM. If you want to increase to the 2 TB, it's automatic. Just you go to AWS, you inform. You can do by yourself. Just increase from 1 TB to 2 TB, one button. So then your RAM will increase automatically. But yeah, there are certain things you have to do. But still, see the level of scaling up or scaling out is much, much easier now. It's just a matter of pressing one button. You log into the AWS and you can see it. I mean, Azure, whoever is using, there are types of servers, right? 2 CPUs, 32 GB, 4 CPUs for 64 GB, like that. So you can increase, the RAM or the server size just like that. So the scaling become much easier now. I mean, increasing your infrastructure sizes or stuff is a lot more easier than what it was. And reduced TCO. I gave you one quick automated example, right? Deploying SAP HANA. So shorter time product, within 1 hour, your system is ready. And the costs, so they have reduced the server management. They have removed the SAP Basis guy, and they have also removed the number of hours what we are spending. I mean, the entire thing. So you see, so a 10 people work has become one guy and in 1 hour. So reduced cost. So shorter time and then lower cost of implementation and ownership. And here, nobody owns. It's simple. Whoever has deployed, and AWS will take care of it. And you may think that AWS also might be investing too many people. No way. AWS and Google are there investing too many people over there, right? So it is just they're investing on the infrastructure. Okay, they are ensuring that whatever they're investing on the servers or the scripts or the automations or whatever it is. So once they innovate or once they do that, that's it. It is applicable for everybody. It is as if like you develop a movie and you do one movie and you release on all platforms, Amazon, or Netflix, or anywhere, YouTube, or anywhere. So it is like one-time investment and it will go for entire hundreds of years. So same is like with this HANA quick start, right? You develop once that automation, that's it. You give it to the entire world. I mean, it's the same link, same thing. So yeah, maybe you may have to maintain it, little bit of versions and all. That's all right. But it has become much, much easier. Maintenance and ownership, everything has been reduced. Okay. That is the best with these hyperscalers. So I have added lots and lots of content in these slides. Okay. Do not get overwhelmed by the content. Okay. So since it's a starting, unless you start working on the systems for at least 3 or 4 years, you will not understand some of these concepts. So just for your informations, but I will try to explain you whatever is needed. Okay. Have the information in slides, but you don't need to understand all of that. Okay. But you just have to understand basics of these hyperscalers and what are the things you may have to, how they have revolutionized the entire infrastructure industry. Okay, that is what you need to understand. And moreover, there is no much scope also, first of all. As I said, as we have seen the thing, reduced cost of ownership. So there is nothing you and me will learn in these hyperscalers. It is such a simple. Okay, like in a HANA Studio, we are looking at some few buttons. So same like this in this infrastructure. So for you or me, there is no control over there also. Okay. So, but it is important for you to understand the basic concepts. That's it. Good. Now, hope by now you have got the some understanding of the on-premise data centers and then this cloud, how things and what are the advantages. So there are now, let's try to discuss about some of the cloud models. Okay. So infrastructure as a service. Okay. So there are three main cloud models. IaaS, you hear these words, and PaaS, PaaS, SaaS. IaaS, PaaS, SaaS. So infrastructure as a service, the yellow one at the bottom. So which means you get only servers, storage, network. You know the infrastructure. Okay. And then platform also. See, first of all, can somebody tell me what do you mean by the as a service? We are talking about infrastructure as a service, platform as a service, software as a service. So what does mean as a service means? So there is nothing you have to do. Simple as that. You just consume it. That is what is meant by as a service. Okay. So this AWS server, just deploy it and then use it. As simple as that. And there's nothing you don't have to maintain. You don't have to do anything. It's a service for you. And AWS is providing you a service, infrastructure as a service. That is what is meaning of the infrastructure as a service. So earlier in on-premise, you have to set up, you have to maintain, and you have to take the ownership. You have to ensure the security of that data center, right? I mean, security in the sense, not the physical security. Yes, that is also important. I'm talking about the attacks, cyber attacks. Okay, that also you have to own. So there's a lot of pain and headache when you are setting up your data center. Now that all thing is gone, just use infrastructure as a service. Just order it, consume it. So as simple as that. Purchase the phone and use it. Simple. So now platform as a service. What does it mean by the platform as a service? Okay. So infrastructure is self-explanatory. I don't have to give you examples. These infrastructure providers. Platform as a service. What do you mean by the platform as a service? So operating system or middleware and runtime. Okay. For example, SUSE operating system. So fine, you are giving the servers, storage and network. Storage means disk space and the network also. What about the operating system on these servers? I mean, if it is a Linux servers, Linux operating system, Linux has to be installed over there. Who will install it? So that is what is the platform also as a service. Or the best example is SAP. Okay. SAP Business Suite. I give you example. HANA on AWS. Just now we have seen, right? HANA is on a AWS server. Quickstart you are deploying. So HANA is as a platform as a service. Okay. Here, just click one button. You got both HANA and infrastructure. So that is the platform as a service. And then software as a service. Just an application. So which means just log in to the application and start doing it. As simple as that. Okay. So these are the three main method or the main ways in the cloud models, the way they provide these services. Okay. So most of our SAP is platform as a service in infrastructure. Okay. So they will provide the, so infrastructure, we will discuss it. Infrastructure provided by any of these hyperscalers, Google, AWS or others, and SAP will put their application on top of it. So end users just consume it as it is. Okay. Now, design phase. So, okay, fine. First, before you migrate to the, you have your application on SAP running on the traditional on-premise data center. Okay. So now, if you want to move to the cloud and take advantage of whatever the advantages I have discussed, I have told, what are the things you have to consider before migration? So which hyperscaler building blocks are to be used? Okay. In the sense, first of all, it's a confusion which hyperscaler I have to go, AWS or Google or Azure. So if you ask me, all three are same. Okay. I mean, the concepts, cloud, it itself is a different kind of thing. Everybody, it's like Linux, Unix and Linux has some standards, right? So cloud also has some standards to deploy. Okay, standards, and everybody has to follow the same standards. Okay, AWS, Azure, Alibaba, Google Cloud, and anybody has to follow the same standards. That is why I say concepts are same, but the namings little bit here and there. Okay, if you work on one Azure, if you work, and then you will be able to work on AWS, and if you work on AWS, you will be able to handle Google Cloud also. So do not worry. Same like database concepts. Okay, so now let's go to this slide. But the important thing is, which hyperscaler? It is up to the customer. I mean, their repo and the deal they got. Okay. So, but if you ask me, one of the more mature provider is the AWS. There is no doubt about it. So none of them can come even close to the competition to the AWS. I mean, I'm not a AWS fan or anything, but I have worked on all three, and I'm telling you. So AWS is the rest of these Azure and all. Yes, they might be getting customers, but they are one of the horrible infrastructure providers, Azure, because they are just into the laptop industry, and now they are exploring this infrastructure. They're clueless on how to run the SAP applications. You see, some of the customers who have moved to the Azure, lots and lots of complaints. Okay, SAP also broke partnership with Azure now. I mean, SAP is not earlier. Last year, SAP was promoting Azure. Okay, Azure and Microsoft and SAP had some tie-ups. So what SAP said is, okay, go ahead with Azure. So the SAP thought, okay, Azure will be able to provide some support, nice support. So go ahead and it pushed some of the customers to the Azure. But SAP now realized that a lot of customers are complaining that infrastructure is not stable, latency issues, failovers, so many issues. So SAP now what they're saying is, you go whatever you wish, AWS or Google or this thing. But obviously, if you ask customer to choose, and the costing also not so different from all three vendors. All three are neck to neck competition in terms of the pricing. So if that is the case, then clearly AWS is the winner. Okay, but Azure and Google may provide lots and lots of incentives. Okay, Microsoft can provide the Windows operating system for free for your laptops. So I mean, like that. So they give lots and lots of incentives. That's why they're getting the lot of customers. Okay, but in a way, if you want to choose a hyperscaler and if you have a business continuity, so then AWS is the best. Okay, so which virtual machine instances? Let's see in the design terms. So which VMs or the mentions are right fit and certified by SAP? Okay, this we will talk. What is the security design? From AWS or whoever, what are the security design they're providing me? How they're going to prevent the attacks? Okay, I mean security, cyber attacks, and how they are restricting the traffic. Because if it is a public cloud, means all the applications comes to that infrastructure, right? So I mean, if you take AWS, it's not only SAP customers, it is other customers and end users. Everybody will be using it. So then all the traffic comes to the same data center. You don't know which data center, so they will tell you. Now they are telling the what data center the traffic is going. But the thing is, again, that is the problem. So what is my security design? How you are preventing from others to access my data? Okay. How do I achieve my business continuity? HA and DR, high availability and DR. How do I monitor my systems? Okay, this is also important. How do I monitor my infrastructure? Because it is in a public pool, or it is in a, what do you call? So it's such a big data center. Everybody using everything over there. So now, how do I monitor my particular thing? And what happens if you reboot my server? How do I get to know? Because it's a service, right? Which means you have no control. Earlier, you have in your on-premise data center, you have control. You have a person over there. A manager, data center manager. You talk to him and you get it. But in AWS and all, it's just service. You order it and take it. That's it. So there is no control. I mean, for example, in your operating system, if you have a problem, you can't directly talk to a Google engineer, right? Android engineer. No. You raise a ticket and that will go to somebody else. There is no visibility. There is no transparency. Okay. That is the case. How do I monitor my systems? How do I effectively scale the resources? I mean, how do I increase my RAM and CPUs whenever I need? Architecture design. What is my entire architecture? So when you are designing, first, you have taken a decision to move to the cloud. When you are designing, so these are all things you have to think. These are all the questions you need to ask yourself, or the architects have to ask. And then build phase. Okay, then you are ready to build. So what are the tools to be used? How do you build it? How do you move your data, right, from your traditional data center to this one? What are the performance consideration? How do you consider the performance? How do I migrate the existing workload? I mean, existing databases or existing things. How do you move there? What are the implementation best practices? Okay. How can I use automation to reduce application deployment time? As I said, deployment, you have to do all these things, set up and all. How can I reduce this one? So build phase, you have to think of these things. Okay. And then operate. Okay. Once you have implemented. So, I mean, I'm just giving you the questions. I will explain, I will answer these questions in later phase when we're talking. Operation. How do I measure the SLAs? Okay, what are my SLAs? I mean, if my server goes down, what is the guarantee that AWS is telling me within how many minutes or how many hours they're bring it up? How do you manage the changes? Suppose if you have your server hosted in AWS, so AWS will upgrade the entire data center. I mean, with the latest security features or whatever it is, they'll upgrade it, data center, but you don't know. So how do you manage that? You have no control. You're just using it as a service. As a customer, you don't have a control over there. How do you manage those changes? I mean, the new versions. So those new versions will not be supported, may not be supported by your application, right? So these things, that is what I mean by how do you manage changes, data center changes, I mean. How do I automate and achieve operational efficiency? So what are things I can automate, and how do I reduce the number of people who are working on the systems? How do I manage security incidents and tap on the threat intelligence? Yeah, this is again multiple applications accessing the same data center. How the security is achieved? How to keep my applications up to date? I mean, if your data centers get updated, how do you keep your applications up to date? How do I address the capacity planning? For example, you are using a 2 TB of data, not the RAM or the physical space. Or if you want to increase, how do you increase it? Yeah, these are all things in operations, your operation phase. I mean, if you're running on Azure, you should think about all these things. Okay, so don't worry. These things just have for information, but once you grow 3-4 years experience, that time if you refer this slide, it makes a lot of sense to you. Principle. So these are the some principles what these hyperscalers follow. Okay, to address all these questions, whatever we have discussed in build phase or the preparation phase or the build phase or the run phase. I mean, run means operation phase. So principle 1, design for automation. Okay, these are some standard principles when all these hyperscalers follow. Design for automation. Their top aim is to reduce the number of people. Okay. So even when 2015, when AWS has introduced these many features infrastructure, to be honest, we all worried. The SAP Basis guys, we all worried because we know the pain and we know how much time it takes to set up a system. So AWS has came up with within 1 hour they were deploying. Initially, we didn't believe it. So then they have given us a demo not. They given us an access. I was working in some. They just give a link and they just told that follow this document, your system will be ready in 1 hour. So initially I was skeptical. So I went ahead and I deployed the system. Within 1 hour, system was deployed. And then after 1 hour, I did the health checks. Health checks in the sense whether the system, it has done the correct or not. Believe me, guys, it is 100% perfect. The only thing I had to do is license, because it's a bring your own license model, because SAP license AWS cannot give you. So it is just that only one simple step I did. I picked the hardware key from the T-Code S license. I went to the SAP portal and took the license and applied over here. That is the only 2-minute job I did. System was up and running. So I was able to use for the training. Yeah, SAP HANA and this thing. See, 1 hour, nothing. So infrastructure, deployment, everything was taken. So they have done the automation in the next level. So in many things they did now. So not only everybody, all cloud providers, not that AWS only I'm telling. So everybody has done it. So I'm just taking an example as AWS because I have extensively worked on it. Now I am working on Azure. Okay. So, and in middle I worked for some time on GCP. But I'm just, if I connect you to one cloud vendor, then the flow will be good. In this entire training. So design for automation. Everybody, all their motive is to design for automation. Simplify things. So yes, we all worried that with this level of automation, we may lose jobs. Okay. So then we all worried. So then later we realized, okay, with that, there is some complexity, but they need people to run that also. To monitor the systems, or Azure also, they need some support. So Basis guys slowly has moved from, but the redundancy happened on the server management level, not on the Basis level. So infrastructure, they have offered as a Linux and then server management support, all these things as part of the infrastructure, but they cannot replace the Basis guys, I told you. So because you need somebody who has the application knowledge or the SAP knowledge. So that is where Basis was safe. But server management has reduced. Even if you now look at it a lot, but yeah, they also got some other new challenges and stuff. But yes, it has reduced drastically the server management dependency. Yeah, especially the infrastructure case. and be smart with state. Okay, so I mean, with the do not. What does it mean is, whatever you have, try to be smart and utilize so efficiently whatever is available. Okay, be smart and get the best out of that. And then as soon as you have the next one, you move it to it, and then you try to always be smart with the state or the level of things what they're providing. And favor managed services. So certain services, for example, the integration services and those things also comes as a part of the deployment itself. Yeah, favor managed services. So which means you don't have to redo those things or manually do such things. It will come automatically. Practice defense in depth. So defense in depth means what you call security. Okay, so this you have to do day in and day out. It's not that today I've defined a security level and then I leave it. So you take an example. This practice defense in depth means, so these are the principles, the hyperscalers on which they operate. So every day or every month they keep investing or they keep looking at the defense or the security. Okay, for example, earlier what we were doing, banking, internet banking, you used to log in with your user ID and password, right? And then long high security passwords. And after that, they have added to know whether it is a human or not, they put some text or numbers, right? They will display 1, 2, 3 or something they will give, you type it. So that to avoid. And then that is also gone. Now what they are saying, they are sending an OTP also. This is a OTP mechanism. So that is what is the practice in depth of the defense. So with the trend or with the level of attacks, what you are having, you need to keep reinventing your security philosophies or the security guidelines. That is what is meant by the practice defense in depth. Always keep inventing and keep architecting and keep designing. These are the strong principles on top of which these hyperscalers have developed. Okay, I mean, if you ask, these are the of any project or anything, right? You have some principles or some motto. So these are the top 5 mottos or the principles on which these guys, whoever is providing the infrastructure, will work. Okay, you look at it, every time they're doing revamping their infrastructures, automations, new automations they'll be launching, always architecting. So what does it mean? Which means they're investing money on these areas. Okay, so now you can think of, there is a scope for too many jobs in automation. Whoever is working on scripting and all these things, that is fine. And architects, yes. So who will be the best architect for these infrastructures? If you talk about only SAP, definitely SAP is the basis guys or the best when it comes to it. But infrastructure, definitely we don't have that control or the visibility, but we may not be that good at. But SAP, definitely we are the one of the best architects who can design on which hyperscaler or considering these things. Okay, good. So SAP on hyperscalers, intelligent enterprise strategy. Okay, so here you need to understand only one thing. Intelligent suite. What is the intelligent? So we heard about SAP business suite, right? So what is the business suite? ERP, CRM, they are combined as a package and they're giving. So it is just that SAP business suite, they renamed it intelligent suite. Okay, you might have heard this word. Recently, SAP calls it as an intelligent suite, not a business suite. Okay, so intelligent suite, what does it mean is, if I have to put it in a nutshell, for the business suite, they have added machine learning capabilities. SAP also has done some innovations wherever they think that forecasting or the predicting the sales or the purchase orders and those things, and interacting with some automated emails, okay, generating reports automated. So such things, they have done some innovations. Okay, that is why they are calling it as an intelligent suite. Okay, so, and then at the bottom you have a business technology platform. We will talk about it later on how they have come up with this kind of innovations. But for now, just understand intelligent suite and business processes and all. You don't need to understand. But intelligent suite is the most important term which they recently calling. Okay, business technology platform, which is nothing but the platform on which they have developed it. So which is nothing but these hyperscalers. Okay, good. So with this, by now you would have got some understanding of the advantages of hyperscalers and their design principles. So SAP has an offering, SAP Private Managed Cloud. Okay, SAP HEC. I'm not sure if you heard of it. So what SAP did is, majority of the customers, SAP HEC, HANA Enterprise Cloud, dedicated, individually designed private cloud hosting. Complete environment with all applications technically installed. The control you would expect with on-premise deployment. Comprehensive suite of cloud managed services. Yes. So SAP told, hey, you have in AWS, Google, AWS, Google, these guys are going to the SAP customers because these are the high payers. I mean, they get so much revenue if they take SAP. Anybody, any partner or anybody, if you start working on SAP, then they'll get paid or they have a high revenue. Simple as that. Because SAP is an enterprise level application. It is not like a small mobile app or something. So AWS, Google, and these guys went and talking to the customers. Please move your data. I mean, why are you investing so much money on your data centers? Okay, so please, you come to our data center. I mean, to come to our cloud. Okay, we will help you in the migration. We will take you, but please come. But the customers raise some concerns. See, man, you are taking my application to your AWS cloud. I don't know where you are hosting. Number one, I don't know what security you are using. Yes, you will tell it. And you are also allowing thousands of other applications also to be here because it's a public cloud, right? Public cloud means that everybody is using and only AWS is aware of it. So it's a generic concept, generic principles and all. But I need control on my servers. I need control on security, network, everything from my side. So that is when this private cloud concept came. Private cloud means, then these guys understood, these hyperscalers provider understood, so to move an SAP to the public, so initially nobody was ready to move, okay, because of these things, public cloud concepts. Because who is ready to see, it is like you are asking a bank, take out your entire data, okay, from your secure data center and you put it on the public cloud where everybody is using. It's crazy. So that bank guy, okay, Bob, thank you. I'm not interested and I don't want to, I'm fine with the pain or this data center is causing. I can live with that, but I can't live with if I put my data in your cloud and if somebody hacks it or somebody takes it, that I cannot leave. I'm sorry, I cannot move. No matter whatever advantages you give or how much flexibility, speed, support, everything you give, for me, data is my heart and I don't want to lose it. As simple as that. So then they have revamped. I said their design principle is always architecting and then always, we have seen in the slide, where was this? See, design for automation and always be architecting. What they did, again, they came up with an excellent ideology, that private cloud concept, which means, hey, BP, you do one thing, this is your own data center and no other applications are coming to this data center. Okay, it is like same as usual data center to you. So they revamped the architecture of the data centers. Okay, so instead of that public cloud, what they did is they have like communities, we have apartments, right? So they have separated it. BP, you have these are the servers. I'm hosting at this particular place, and you are the only one using it. Don't worry. It is as similar as to your on-premise data center, and you are also getting the excellent benefits of this cloud. Okay, deployment, speed, automations, and all these things, benefits you can use, but I can cater you this service. And then AWS did it. I mean, before this, Google and Azure did it. Then Google also started doing this private cloud concept, which means it is more or less similar to your on-premise data center. You have a control and you are getting the benefit of the automations and all these things. See, such a beautiful concept. So this is what convinced the SAP customers, definitely. So now SAP customers felt good. I mean, some of them are ready to move. The reason is, you are getting a data center, your own data center kind of thing, but Amazon is managing it. So Amazon was managing the data center and all these things. Okay. So, and then you got the support, service, features, everything. You are getting literally new data center. And you don't have to worry about the data center, first of all. And you also got the control. So you can ask them to put the new security guidelines or these if you are not okay with that. So that part you have got, and you know that none of the traffic is coming to that data center. Okay, that is an excellent, again, a business strategy by these players, hyperscaler players. Then they convinced customers, okay, let's go. And then SAP also convinced that with this kind of concept, more or less similar to the private, so they named it as a private cloud. Okay, instead of putting it a public cloud, private cloud. Now you understand public cloud. Public cloud means whatever you request, it will go to a particular data center, and many of the people also using this. Private cloud means it is dedicated for that customer or a particular company. Okay, so SAP has started its own enterprise cloud, a department within SAP. There is a department in SAP HANA Enterprise Cloud team. They will be supporting around 2,000 to 3,000 customers. Okay, so what SAP said, fine, SAP application support I can take. Okay, AWS, Azure, Google, you do one thing, you provide me the infrastructure to the customer. Okay, you provide the infrastructure support to the customers, and I will host my application on top of it. That's it. So SAP is providing the, application support, and these guys are providing the infrastructure support. That's it. This is the HANA Enterprise Cloud model or the private cloud model. Or customers also can have an option directly talk to the, if you have, if TCS has a basis support, then you don't have to come to SAP, right? So what you can tell to your customer, Johnson & Johnson, okay, you move to whichever cloud you want, I will provide you the basis support. Because as a basis guy, it doesn't matter where it is hosted. It's AWS or wherever it is. So your support model is same. But yes, server management and all, it varies. But for you, there's no difference. So this is the concept of private cloud. Now let's go. So deployment models by SAP on hyperscalers. Okay. So here left side you see certified infrastructure as a service platform. Okay. So fine. AWS, Google, these guys went and they talked to the SAP customers. See, anyway, SAP is not providing you the infrastructure. So please get out of your data centers. We will provide you the private clouds. Okay, they said. But still customers are not happy. Customers, some of them, no, majority of them are not convinced. So they might felt it is interesting, but still that is not sufficient for them to take a decision to move to these things. Okay. See, these customers, why SAP is, this is also important. So it is just that they trust SAP, 100% with their full heart. If they don't trust SAP, then, they can't survive. The reason is because their entire business is hooked with SAP. So they have to trust SAP. There's no other way. And SAP also always good with their customers. So compared to the other vendors or others in the market, Amazon is one of the best customer-centric company. And after that, SAP is one of the best customer-centric company. So SAP is not only customer-centric, it is also partner-centric, which means it wants everybody. I told you, win-win situation, win-win strategy, SAP. SAP is not about money or, yes, they make a lot of money, but for them, it is important that the customer or the partner also succeed or get revenues out of what they do. So now what happened, when these Amazon, all these people went to the SAP customers said it is interesting and it is all good, but that is not sufficient for them to take a decision. So they came to SAP and asked, SAP, are you okay with going with these infrastructures? See, they're giving us a lot of these things. Are you okay? But some assurance we need from SAP before that. See, that is the level of what you call customers relationship SAP has built over the year. So when they did it, SAP has thought that no, we don't want you to just go and migrate. So I want to certify. Okay, that is what certified IaaS platform. This is the word. See guys, it looks so simple. This is the background of it. So certified IaaS platform. You see, right? There are a lot of things. It is an SAP certified application. It is an SAP certified infrastructure. It is an SAP certified. So anybody, Alibaba Cloud Computing Limited, Amazon Web Services. So these are the players. Google Cloud Platform, Huawei Technologies. Huawei is one of the cloud in China. IBM Cloud, Microsoft Azure, Open Telecom Cloud. I never heard of this. But so Alibaba, Huawei, why they came into picture? Alibaba, Huawei, China only. China's policies, right? They're ruling. So they want their own data center there. So China is a different thing, global market. China do not want to expose anything to anybody, but they want everything from the entire world. Okay, they will copy the Apple phones, they will copy everything. But China do not want to expose anything from their country. So that is why they want to have their own data centers in their country. That's why Alibaba, Huawei, majorly catering to the China. So then, because of this Cold War and all, so now globally also they are not taking this Alibaba and Huawei outside. There was a big scam, big filing last year, right? Huawei. So this one is 5G scam, 5G.
What sets ZaranTech apart in SAP corporate training? It's our unique blend of expertise and innovation. We offer customized courses tailored to each client's needs, ensuring relevant, targeted learning. Our vast trainer database brings you wisdom from the best in the field. Need resources? Access our extensive training material repository anytime. We are all about measurable results, providing detailed student metrics to track progress. And we don't just teach, we build community. Join our thriving social media network, connecting learners beyond boundaries. With ZaranTech, you are not just training, you are transforming your SAP expertise.
So with the security vulnerabilities, America blamed Huawei, and then it was a huge project. So the billions of dollars Huawei lost. Okay. So this is very important, guys. So what happened when the customers has approached these guys, SAP, then SAP has to give an assurance to these guys. Okay, you are fascinated, you are interested in it, but certification. So every infrastructure SAP certifies. What does it mean? There is a dedicated team within SAP. Okay, so architects and all, there are good people. So what they do is they will test and every version of the infrastructure what these guys provide. Okay, and these guys have to pay for the team for SAP. Because if you want to sell you, because SAP has put that guidelines, because it's important, because my customers are worried that your infrastructures are supported or not. So all these infrastructure guys, whenever they develop something or a new server or something, they will give that server to SAP. Okay. So I have seen it when I was involved of, okay. As a customer project, I have seen in the trucks, these people, from they send these servers to SAP office, head office. So SAP will install in that hard, and they send in engineers also. So they will come and they will install in SAP data center. So SAP will test its applications, business suite, ERP, all these things. They will install and they will test it. They will verify. They will prepare a report. Okay, stating that yes, this server has so and so latency, so and so things, and it is good. And they give a stamp, certified. So Amazon is certified, Alibaba is certified, Google is certified. So all of these guys are certified. And every time they release a new version or new thing, they have to get it certified by the SAP. Okay, which means SAP is assuring that these infrastructure providers are good and these infrastructure can have the SAP running on it. So now the customers are assured. They felt happy. Yes, the vendors also, the providers also good. They're giving the data center and all these things with private cloud concept. And also SAP has certified the infrastructure, which means we are little confident. And now we are good to invest money and migrate to the, these clouds. So certified and supported by SAP HANA hardware directory. For you click on this link, you will find what all things are certified. Okay. So this cloud appliance library, it is relevant. In one word, if I have to tell you this, SAP Cal, put it in Google, note it down, guys. SAP CAL. Okay. So it is also one of the best innovations in SAP, which means, so this is a complete automation of deploying systems. So SAP Cloud Appliance Library. So you just go there and you select the system, ERP system or BW system or whatever it is. Then it will deploy you on the infrastructure, whatever you want. AWS, Azure, Google, that's it. So it's a setting up a complete automation of the installing an SAP system, SAP Cal. But as I said in the beginning, our discussion, let's restrict to the, what we call the infrastructures for now. You got it? So now customers are happy. Customers have got the assurance from SAP because SAP has certified them, and they are also getting the benefits of the private cloud, and they are good to move. And then we talk about how exactly we move our systems to the this cloud. So now Next, we discuss about how we move to the cloud from the existing data center to that. Again, it's very complicated and very difficult to understand, but still I will try to restrict to the basics, okay, so that you will get a fair idea of how they do it. So fine, this is how the customers, some of the customers were ready to move to the cloud, considering the fact that SAP is approving those infrastructure, okay, because they can't trust anybody else apart from SAP, because they have been with SAP from 20-30 years and they knew that their data is safe with them, okay. And moreover, SAP assurance always to the customers is, even though your critical data goes through my system, I do not do anything. I mean, they never did and they don't do also. SAP has a very clear guidelines or the policies when it comes to the data. And SAP, even if you go to the SAP will tell that I host all my data centers in Europe only because of the government guidelines over there. Okay, so good. Let's see. What are the deployment models or the in today's? Number one, private cloud. Okay, so private cloud means it is like on-premise, either on-premise or the dedicated data center by the hyperscaler or AWS or this case, and then private hosted cloud. So this SAP will take care. Okay, so SAP hosting partners, AWS, GCP and all, and then SAP will support the application, and this is a private hosted cloud, SAP HEC team. So SAP has a team where they host SAP on any of these cloud providers, and then they take care of the support, which means TCS and others you may not need to support. SAP only provide the basic support. You understand? Okay, so that is there. But SAP support is a little costly. That's why many customers they do not come for this SAP HEC. Okay, what do? They go for this one, third option, infrastructure service as a cloud hyperscaler. Anyway, Azure, GCP, and AWS they have agreed. Alibaba Cloud, they have agreed. They can set it as a private cloud, or some customers are okay to move directly to the public cloud. Okay, and SAP Basis support TCS, like you are supporting Azure, right? So this is your model. So your customer hosted systems on Azure, and now you are supporting. So then the customer can go to his trusted vendor for the Basis support or SAP support. And then platform as a service, cloud platform, it's out of our scope now, leave it. So it is nothing but a app they can develop on this one platform. Software as a service. So I'm not sure if you heard these SAP success factors. Sorry, it is a learning tool or HR related. It is software as a service. I mean, with that, sorry, why this slide? So directly you can consume as a service. I mean, they will just give you a URL. That's it. You work on it. It's as simple as that. So that is the software as a service. So you will not have neither the SAP system access nor the infrastructure access, nothing. So software as a service means you just get an URL and you work with that URL. That's it. That is as simple as that. So you have no control over it. You are just like an end user. Okay. Such kind of solutions also, SAP cloud solutions, majority of them are like SaaS. For now, you just understand the middle one. I mean, it doesn't matter as a basis guy, whichever is the case, your support is same. But the concept is, let's assume that customers are hosting on these hyperscalers. Okay, how do they move their data from their existing data center to cloud, or what are the strategies? How do we move and how do we build the systems and how do we migrate them? If you ask me, how do we migrate them from their own data centers to this thing? Okay, so this one, SAP Business Suite. So let's say currently, I'm looking at the left side. Okay, so they have an ERP6, EHP8 on any DB, which means any DB means this term like Sybase or Oracle or DB2, any database if they're running. So before they move to SAP S/4HANA, I told you simplified suite for HANA, S/4HANA, which is the latest version of the business suite. I mean, they call it as a different product name, but it is more or less like an ERP. Okay, but it is much faster and the code line has been reduced. So it is very faster ERP. Okay, if you have to put. So basically, you have to move to the HANA. If you want to move to S/4HANA, So this slide explains how you move from business suite to the HANA. Any DB to first you have to go to HANA. That is one option. And then you migrate the data, the system conversion from ERP to S/4HANA. That conversion is out of scope. I mean, there are ways to do it and stuff. Let's not get into that. But this is how you get to this thing. But for us, the important thing what we have to discuss is about how you move the data or the infrastructure. That is our topic today. So keep in mind, where is this thing? Most SAP tools work for migration. Okay, so there is a tool DMO. I mean, a downtime minimize optimize tool. It's a SUM tool. It's a SUM tool we discussed, right, for upgrades. The SUM has an option called DMO. What it will do is it will migrate from any DB from Oracle to HANA, and it also do the upgrade. Okay, two things in one shot. Okay, so here you see this slide, DMO with system with this diagram. So you have a SUM tool, and then you have any DB. So what it will do, it will migrate to HANA DB, and then it also do an update. So yellow line, migrate plus update. If you have, so in one shot, in one time, this is to reduce the downtime. So or else you have to do two activities. First, you migrate from any DB to HANA, okay? And then again, you take a downtime and then you perform an upgrade, right? So that you don't want to do. In one shot, you want to do, migrate it to any DB and then you update it. So that is possible with SUM with the DMO option. Okay, downtime. So just know that for now, we have a DMO tool, a SUM tool with a DMO option where you can do two things in one shot. So this is the thing. So left side source data center, you have system with any DB, and this is the target data center, a new data center and the hyperscaler heck. So you use this particular tool. Okay, for now, just know that there is a tool to do that. Okay, now, so methods, so sizing, methods to move data to the hyperscaler or AWS cloud or the new servers. Okay, online copy, most of the people do, and then physical device. So, for example, your data center is in Frankfurt. Okay, your existing data center, on-premise data center. Now you have decided to move to the AWS data center or AWS hyperscaler cloud. So now you have a 2 TB of data, 4 TB of data. You see this one, 4 TB yellow here. I put follow my cursor, amount of data. So you have a 4 TB of data. So what you have to move? Number one, you have to move the data from your existing Frankfurt data center or to a new data center which is in London. Amazon Cloud Data Center is in London. So you want to copy the data. So how do you copy the data? So it is simple. I mean, it is like Google Drive. So hope you all use the Google Drive. Suppose if you want to copy the data, I mean, if I want to share you the data, what I do, I will upload my content in the Google Drive. Okay. And then Google Drive link I will give you. Google Drive is nothing but a storage place. So then you can access from anywhere. Same way, this guy from their data center, from their on-premise data center, they have a upload to a drive or a cloud drive. So there are different names for that. Google Drive, the name. Okay, Google Drive. And this one, Microsoft OneDrive. Have you heard of it? OneDrive. And then Amazon, they called it as an S3. Amazon S3. So it's a different name. It doesn't matter. All of them do the same functionality. Okay, it's a drive where you have to upload this 4 TB of data. And then in the Amazon data center, they will download that data. It's as simple as that. It's a simple concept. But the problem is the network bandwidth. So if the speed of your data center is 600 Mbps to upload and download also this one, you have to calculate the time. 4 TB data, 600 megabits per second, you calculate, it will come just simple calculation, guys. So, I mean, 4 TB by 600, how much it becomes, just check it out. So 16 hours, so and so time it will come, total transfer time. Okay. So it is too much. It is just for copying the data, you are taking, you are wasting the downtime. You understand? I mean, too much of time is going in this one. And let's say you have a 20 TB BW system, 20 terabyte of data. And, it is not that one system you are migrating to the, I mean, you may think that, hey, my system size is 500 GB only, I will do online. Here we are talking about data center migration, guys. So you want to shut down your on-premise data center and you want to have this thing. So many applications have to move there. Maybe phased wise they do. First, some applications will be moved, some later. But you consider if a customer has decided that, okay, let me shut down my data center and take the new one completely. So then we are talking about 100 plus systems. So which means 100 TB, 200 TB of data. Okay. So that is the tricky part. So if you take 20 TB, so the transfer rate, if you look at it, so 600 Mbps and it takes 3 days, 9 hours. So it's to lose unnecessary things. So what they do is, so to avoid that, there is an option to call physical device. So Amazon will send them the hard disk. Like I send you the hard disk, simple terms, same concept, hard disk. They will send you a physical device in a truck, secured truck, and that is proctored, and they don't know anonymous trucks also. They don't tell you that this is a data center truck or something. There are ways how to securely take this data. So they take trucks, the disks are sent to your existing on-premise data center. So then these trucks, I've seen this, I mean, where such data is copying. So how these trucks are managed. So these guys will upload the data. I mean, obviously the physical device is very much faster. So, and they put it in the trucks. And you may say that the data, somebody can take the data, right? No, it is completely encrypted. So unless your data center engineer goes to the target location, okay, so there are methods. So, I mean, encryption algorithms will be there. Until your target, your source data center engineer will go to the site reliability engineers they call. Okay, that is the name. So your site reliability engineer from your existing data center will go to the target location also by flight or some thing. So he will unlock the data in the new location. Okay, unless you unlock it or unencrypt it, they will not be able to do anything with the data. It is as useless as it is. Okay, so such kind of strong algorithms are there. So they will send the truck in an anonymous truck. It will be carried to the new data center or the new cloud location, and where they will download it and they will build. They will copy the data. Okay, this is so it looks so silly and simple, but this is how it has been. Data has been carried out. And this is the most important thing, even though it looks silly. So I'll tell you why. When you are doing a migration, and if you're copying the data, most of the time in this network, maybe your server or their server, there are the chances of data getting corrupted. Okay. So which means, suppose if the copy fails in the middle or due to the while downloading or uploading, so you don't know, you go for a coffee and you come back and then you see that, okay, it is running, but somewhere it would have corrupted. So it is very important that this 16 hours you keep monitoring, or you place an algorithm, or you place some monitoring mechanism that this doesn't get in middle, get broken and restarted. So it's very important. Okay. So many cases, these things happens while copying the files get corrupted. So you should not let that happen. Okay. There are secure channels when you are doing that. So you always have to follow those guidelines. Okay. So this is how you do it. Now, sizing, how to move the data. Okay. So this we discuss now. 1 second now. Okay. So you have a customer network here. So you see the right-hand side. And then you have copy to S3 bucket, which is nothing but Google Drive or OneDrive, S3 bucket. And from that S3 bucket, you take it to this particular region's data center. Okay, it's as simple as that. Then you download. So now it comes into the AWS domain. Then you can start building the instance and copying this data. It is like within the data center, you are doing everything. Or there is an option from the customer to directly AWS will put a cable. If they are 100 kilometers or 200 kilometer distance, right? So AWS direct connect, which means like you connect LAN cable, they connect a cable from there to here. Then suppose if it is a huge data center, so then directly from there to here, it will come. Or if it is a huge data center, what AWS will do is, if it is a private cloud concept, AWS will do, I will set up a data center next to your data center. If they get the land, nearest 10 kilometer distance or 20 kilometer distance, they will purchase a land, and nearest to that, they will set up a new data center and they will take the data, because the whole objective they move to AWS is, flexibility, automations, and all those things, benefits, right? So that's what they do. And they will put a LAN cable connection from that to this one. So it all depends on the investment and the placing. Okay, you have to copy the data like this. Good. So now, the important thing. Okay, now SAP, let's go with the flow. SAP has certified the thing, customer has agreed to move, and then they have sent the data to the AWS data center, either through direct connect or with a direct connection cable. or through tugs or through the network, whatever it is. Now the important phase comes. Testing strategy in the cloud. So do you directly build your production system over there? No. So, okay, your data is available in the target system, target data center. What you do first is you prepare. So this is the cycle you have to follow. Prepare, scope, execute, monitor, mitigation corrections, and wrap up. What does it mean? So we are not going to the production at all, our production landscape. We are not even building development or test or production system. So here you want to run a mock. Okay, you build the system, you define the scope, and then manually automate it. You build a random system, and then you monitor error behavior for 1 month or 6 months or 8 months, and then you take care of the mitigations or corrections. Okay, good. So what happens is you don't take your direct landscape to the first you build it. You build a mock system, and you want to test for your workload or the application load whether the data center is working fine or not. And performance you have to monitor for a couple of months, right? It is not as simple as you take and you build and you face and you come back. There's no way back. So it is like a 1 year or 3 month, 3 years plan. Okay. For example, I'm working on a project where it is a 3 years plan. Okay. They have multiple data centers. We will take one data before the data center migration itself. We ran it for 6 months. So you need to understand whether, suppose if the data center guys, you have to understand the behavior of the data center also, right? Theoretically, they would have explained, or how frequently they are updating their patches in the data center. What is the network stability? So what is the network bandwidth over a period of time? So even though your Airtel guy will tell you 300 Mbps as a speed, suppose if you are getting 100 Mbps, you are worried, right? Theory and those things you have to address. So we are not talking about building the system here. We are talking before you make any system build. So you have to do this exercise. It's a huge exercise. You have to send your best people from your company, basis guys, architects, and then these guys have to monitor the systems for 6 months to 1 year, mock systems. Okay, how the AWS, how frequently they are upgrading their thing. When they upgrade, is there any impact on my application, or how I have to prepare the strategy? So with that, you have to prepare a structure or the guidelines. Okay, every week AWS will send the new fixes. Okay, with this, I have to put some tests or error behaviors with those upgrades. Do my application. It's a mock before you actually build your development or test systems. Your production landscape. This is what I'm talking here. So once you run for 6 months, then you wrap up. You prepare a summary report. Hey, AWS has promised so and so Mbps of speed. Yes, the speed has been met or not met, and the latency is so and so, and these many times, or they have done the patching to their servers or OS upgrades. So these are the frequency, these are the timelines they have done, and at that time we do have some issues. So these are the issues which we may have to look at. So such kind of report those engineers will prepare, basis guys and the server management and infrastructure guys. So if you use report, so based on this report, then the deployment decision will be taken by the organization or the customer. Deployment decision, based on infrastructure was approved by SAP, and then they also ran a mock test. Customer also ran a mock test for 6 months. So then summary report looks good, and then they go with the deployment decision. Taking a decision or moving a system from one infrastructure to another infrastructure is not as easy as we think. It's not as easy as we just change our laptop. Believe it. It is very, 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 very complicated. What we are talking about the business data or the live data or the most important data. So you cannot just play around with the data. It is very, very critical, in any organization. So that is the most important for, it's not only for banking, for oil and gas, for automobiles, retail. So if you lose your data, you're gone. Okay, that company is gone for sure. So having a backup or whatever it is, they should have that data and they should have their application up and running. So that is why you do these many preparations. Why the IT spending is more for these companies. Why they are spending crores and crores of money. So I know why TCS has to support that customer, whatever your Azure customer, SAP. Okay, why do we have such a huge basis support guys or the web guys or functional guys supporting these systems? Because to ensure the business continuity and to ensure that this everything is available at any point in time. So it is not a simple decision. It is like 1 year, 2 years of planning with the strong people, architects sitting together, brainstorming the ideologies, methodologies. So these are all things they will prepare. This is the execution methodology. So we are just still in a phase of preparing or taking a decision. Okay. So this is fine. I mean, this is just for theory. Let's not worry about it. Adoption and migration, optimization and operations. Yeah, 3 things. So number 1, strategy and planning. So the customer in the previous slide, customer took a decision, wrap up based on the mock test on the new. So he moved his data to the new cloud data center. And in the cloud data center, they ran the application for 6 months or 3 months or whatever is the time. It depends on them. So they ran a support and customer took a decision that let's go ahead. Okay. Now you have to define the strategy and planning. Okay. And then adoption and migration. So in the sense, how do you take your production system, production landscape, not the production system landscape. First, you have to take the development system and then test system and then production system. Production will be the last. So in these phases, you would have learned a lot of things. I mean, mock test, and then implement them while you're doing the development system, and then move your test system to the new infrastructure, and then your production. So that is what adoption and migration and optimization and operations. Once you move all 3 systems, then you have to work on the performance tuning, or if any unknown issues or those things you have to tune. Okay. So monitoring and alert. So training and awareness. So these are the things. Once it is live, we call it as a go live. So once it is live, so you have to think about how do you ensure the monitoring is in place, alerting is in place, training awareness, and because the consultant should be aware on the new infrastructure, right? So, and the cloud change management and the cloud changes as per your summary report before you did mark how frequently AWS is upgrading their servers. So as per it, so you have to plan your strategies or inform your business that downtimes and stuff, etc. Okay, so this is how you take your production to the cloud. So these are the different phases, and these are not important for you. These are for the cutover managers, whoever is doing these cutovers, or managers whoever is dealing. These are the sequences. So we come in the adoption and migration. So we as a basis guys comes into adoption and migration, because migration has to be done by basis guy only, guys. Okay, don't think that somebody else will do. Migration means using the SUM tool or DMO tool or export import method or backup recovery. Okay, whatever the method you follow, you have to do the migration, and you have to bring up the application, and then after that you only have to provide the support also for that application. Okay, good. So this slide will 2 things here. Left, x-axis you have effort, you have a business benefits. So number 1, 2, 3 here: rehost, replatform, transform. Okay, these are the 3. Rehost means, as I explained, one data center to another data center. There is no change. So you are just moving in one the data as it is, lift and shift. It is called. See, he called homogeneous migration or the lift and shift. So it's just that you are changing it from your existing data center to be a new data center or the cloud hyperscaler hosting. Okay, that is called lift and shift mechanism. Okay, so it means as it is, you are taking it. So some customers, okay, anyway, you are taking it to the new host. Anyway, I'm asking for the customers some 2-3 days of downtime. Why don't you replatform it? Okay, so replatform it in the sense, for example, you have a Windows system here. Okay, I mean your Java systems are all Windows. So replatform means, so this Azure and these AWS and all, they don't support these Windows. Okay, I mean because of this costing, they support but only limited. But especially for SAP will not certify any infrastructure with Windows. Yeah, hyperscaler especially. So that is the way of putting it down. I mean putting it separate. So in the hyperscaler, any AWS, or because SAP has to certify the infrastructure, right? SAP will not certify Windows to host any SAP application. So it's simple. So if your existing systems are on Windows machine in your current data center, what you have to do? Replatform. I mean, migrate to SAP HANA on a supported OS platform so OS platform has to be replatformed. Okay, you have to migrate to SUSE Linux or whatever the Linux you want. any Linux operating system. And then, for example, you are using an ERP, fine, operating system can have any database. You can have Oracle, Sybase, or whatever it is. There is another option, transform from ERP to S/4HANA. So if you take 4 days of time, you do all these things in one shot. First, you move from to the new host, and on the new host, while you are doing to the new host, you migrate to OS migration. So OS change Windows to Unix or Linux, and then you also do a conversion that is called conversion, ERP to S/4HANA. In one shot, you can do all these 3 things. Okay, so if you do all these 3 things in one shot, which means all your 3 things will be done in one downtime window, so that or you have to plan 3 times and so much of efforts. Okay, to reduce that, you go with this. But many customers will go lift and shift. Let me tell you, this one, lift and shift, the bottom one, rehost, because they would have already upgraded or replatformed to SUSE, because when they migrated to HANA, they would have done the replatforming, because HANA is supported only on SUSE, right? So, and then their application data also they would have converted. So it's just kind of lift and shift, many customers. Okay. The recommended migration ops, same thing, whatever I updated. So you see left side, business suite, start release on any DB, and then convert it to SAP HANA first. And then from SAP HANA, you convert it to the SAP S/4HANA. I mean, ERP to S/4HANA, that is a system conversion. Or you build a new system on the new cloud and you can transfer the data. Okay. So that is also possible. That is called HANA, what is that? SLT, transmission of some data through SLT, HANA SLT. There is a thing. Okay. But many customers do not recommend it. And as a basis guy, even I don't recommend it. It is all tedious. It can lead to some data inconsistencies and stuff. The best is follow this. So if you have an ERP 6 and EHP 8, any DB, Sybase or Oracle, first you move to the HANA. I mean, export and import, basis guy has to do. Okay, build the new system and test it for some times. And if ERP to S/4HANA, you move. Do a system conversion. That's it. Okay. So supported SAP standard upgrade and migration tools. What do we have? SUM upgrade. Suppose if you want to do ERP to EHP 7 or upgrade, I told you SUM tool you use. And then installation, you use SWPM, software provisioning manager, and database migration, DMO of SUM, same. So don't get confused. So here only 2 tools. One is SUM, one is SWPM. SUM for upgrades. But if you want to migrate, so there is an extra option I told you, right? Migrate and update in one option. SUM only have another option, DMO, downtime minimized optimization. It has an option where you can do migration also. So these are the 2 tools you have to remember. Okay. So now, SAP landscape rollout strategies. So again, I told you, we have 3 system landscapes, right? You see this diagram, development, test, and production. So it is strongly recommended not to go with the development also. I mean, you have moved your data center data to the new cloud infrastructure. So there, how to start, which system to start? So a strong suggestion is don't start with the ERP. Okay. And no customer will do that also. That is a strong suggestion. So you start with non-business impacted systems, that too sandbox system. First, you start with the sandbox and BW, because BW doesn't have a direct end user impact. Okay, maybe reporting and all might be slow, but it doesn't have an direct end user impact. So take such kind of systems. Then you see in that process, you learn, you improve your implementation plans, you improve your technical steps, you know whom to contact, and those stuff will be streamlined. And then again in the BW, you start with development and then test and then production. So and wait for BW system behavior for 3 months or 6 months. And you adapt, or you prepare all the plans and steps as per those things and fix all of them. Once you think that your BW landscape is perfectly fine, then go to the BIP, business intelligence, then go to GDS, then go to EWM, and S/4HANA should be your last one to be migrated. S/4HANA is nothing but ERP. Okay, the ERP should be the last one, should be implemented. Okay, be careful. This is how you have to do. So now you understand the why SAP projects take so long to implement or to deploy? Yes. So it takes at least 2 to 3 years, guys. Okay, 2 to 3 years to migrate to the cloud. It is not as simple as it. Okay, so and in this 2 to 3 years of phase, the customer's data centers or the own data center should be up and running. Okay, I mean, in case in middle something happened, so they should have. So once these 3 years, you migrate everything on all systems live on the new hyperscaler, then only they will shut down their old data centers. Okay, so it is a 3-year plan. It's not 1 year, 2. It depends on number of systems, but if you take BP or Unilever or such big companies as an example, it's a 2 to 3 years of project. Okay, taking them to the AWS or this thing. Good. So with this, now you understood the concepts of what are the methods and ways of taking it to the strategies to take it to the hyperscaler. So now we will talk about the hyperscaler infrastructure. A little bit about it. So we are talking about their hyperscaler data centers, right? So right side you see, so here they have multiple data centers. So they call it as a region. So in America region, in Africa region, or APJ, Europe region. So they have availability zone nothing but in that particular data center, availability, where you can host your application. So these are the terminologies they use. So there are Azure 60 plus regions worldwide. Okay, which means 60 plus places they have the data center. AWS 24 regions, 77 availability zones. Okay, so which means AWS has 24 regions, means 24 APJ, America countries, 24 countries or places, 77 availability zones, which means there itself they would have separated by zone wise, or the private clouds they would have installed. GCP 24 regions and 73 zones. Okay, so now you tell me which one is the biggest among these three: Azure, AWS, or GCP? So it's the AWS. So 77 availability zones means 77 data centers it has. Fine, regions are, keep it aside, countries, and then 64 plus regions worldwide. So they're saying regions, which means Azure has deployed a region is nothing but their availability zone. That's it. 60 data centers they have. GCP has 73 data centers. So which is very competing each other. All of them are competing neck to neck. I mean, Azure and AWS. So which means they all have nearly more or less same number of data centers. But having a data center itself is not sufficient. So, I mean, customers have to move, right? You built a house, I mean, you built an apartment and customers has to purchase those flats. Then only, so AWS is the 77 zones. Many of the customers have already purchased. It is like that. So remaining, Azure is catching up. So GCP is the last one. I mean, it's not enough. Yeah, it's slow, basically. Google is very good. I told you when I was giving that example of Google stores the data. So that's why customers don't like Google. Okay, at least AWS and Azure. So Azure, they have an experience, right? Azure, you might be using Windows machines and all. So I mean, at least Microsoft have never caused any problem to these because laptops also important. Your personal data to the organization data, because everything organization related PPTs, Excels, everything happens in your laptop. At least people have trust, or the customers have trust with Microsoft that, okay, Microsoft did not do anything with the data what they have. And then AWS also, the AWS have straight away proven. I mean, they have taken a few customers for free of cost or something, SAP, and they put it on cloud. And with the example, they have shown to the market that, yes, these applications can run and these guys are saved, so on, so things, and they have proved it directly. They took the risk. But Google, people still, customers still not trusting. And moreover, it's not about the data. It's not only about the data. And Google's, the ideology or the methodology of working also customers do not like. See, Amazon, it has a strong brand value stating that we are customer centric. You take retail or anywhere. So Amazon's, Kindle devices, Amazon always focuses on the customers, and that kind of this thing is there. Microsoft, yes, they already have an establishment with all corporates with the Windows or tie-ups, so it is becoming easy for them. But for Google, it's not a cakewalk. because Google, so the way it has evolved in the market, Chrome and all fine, YouTube and all, YouTube also Google's, I mean, they all belongs to Alphabet. But the problem with Google's is their aggressive ideology. I mean, the way they want things to be in a different way and stuff. And moreover, with the data also, they have these problems. Okay. And moreover, they're not good with enterprise handling data. Okay. Enterprises, like such a heavy data. So they're not good in terms of providing infrastructure. And moreover, first time they're coming into the infrastructure. So nobody is, not many customers are so interested to go, because it's not only about the infrastructure and building a data center. You have a money and you can build a house, right? You can build a house. Suppose if you build it on a forest, I mean, if you don't have the customers to purchase the flat, I mean, they don't trust you. I mean, unless you are an established brand and you say that you have engineers to support the data center and you have the employees to take care of it, unless you prove your service capability also, nobody will be willing to come to you. So this is the problem with Google now. Okay. So good. So these are the reasons in data center. Elastic computing. This elastic computing is nothing but okay. So there are nodes I have given here: AWS instance types of SAP, node Azure instance of type, GCP instance of type, so and so. So you just check those nodes. There are various types of instances available, the servers available. Thing. Elastic computing, just keep it as it is. So, I mean, scale up becomes easy. Suppose if you are using 8 CPU, 32 GB RAM, and then tomorrow you want 16 CPU, so it can be easily extended. So that is the strong advantage of these cloud providers. So in all three, that provision is there. Okay, that is what is the elastic computing. Even with the CPU, RAM, and storage also. You have a 2 TB of storage now, disk space. Your data is increasing. You need 4 TB, you can extend. So you can extend like that. So it is much easier. Yeah, scale up or scale out, or increasing your storage or your network bandwidth also you can increase. So that is the elastic computing. Elastic means you can increase as much as possible. Okay. So, AWS reference architecture, don't get scared by looking at this diagram. Okay. I just want to show you this thing, the terminal, what all things you have. It's just a simple architecture of high availability. Okay. So just understand high availability, how it is achieved over here. Okay. So you have availability zone 1, availability zone 2. Okay. So it's a private cloud. Just keep it as AWS cloud infrastructure. So the red one, just focus. Okay. SAP HANA and then SAP HANA secondary. The red ones just focus there. I'll explain you high availability, what happens. So availability zone 1 means just think that it's a server zone or the network zone 1. And this network zone 1 where this server is hosted. Okay. So these two are different servers, and then a HANA system replication. Okay. High availability means, so you have this HANA primary, this left side one in availability zone 1. So primary. So your SAP business suite is running on the HANA. So in case of something happens on HANA, this primary, so it will run on the secondary node will take over. Okay. So the end user doesn't have any impact. Okay, this is how high availability is achieved. So how your secondary is always in sync with the HANA? You may ask a question, right? How does my secondary has the same data as the primary? So that is what is called the HANA system replication. So every second, so whatever the changes are happening on the primary node will be applied on the secondary node as well, so that your secondary always in sync. So always in sync. If something happens on the primary node, it takes. So this is a simple high availability concept. So these remaining architectures do not go. It is too much for you for now. So once you are experienced and you understand these things, just you refer to these slides. It will help you. I can explain you, but it is very difficult for you to catch up. Okay, these are all architecture level and a lot of components, networks, the internet gateway, router. So, I mean, you see the end user. So before he comes to this, these many things like I explained firewall, right? So internet and VPN connection. So you need to have VPN is nothing but a kind of firewall. VPN connection, then you have a customer gateway, router. So these diagrams we explained in the network security. Okay, so yeah, you can simply connect it. So you have a router and then internet. So it comes to the router and then request will be passed to the SAP Business Suite application and then your HANA database. Okay, so Amazon S3 is nothing but like a Google Drive. Okay, S3 is a storage. So here you see storage. Okay, AWS Direct Connect, I told you. It is from one data center to another. But don't go with these terms and stuff. Okay. It is not important. So each term varies. In Azure, they have a different name, and in Amazon, they have a different name. But what you have to understand is, in case I have to develop a high availability, I need two availability zones, or the two data center, not data center, they call it availability zone. They can be in addition to next each other also. Okay. In availability zone 1, so I will take the, I will put my primary, and in availability zone 1, I will put my secondary. Because why can't you put the same secondary also in availability zone 1? Suppose if you have a network issues, means both the servers have a network issue. So that is you don't want, right? A high availability you need. So that is why you put it in a different zone. Okay. So that's how you configure the high availabilities. So this one, high availability and disaster recovery architecture. Good. So perfect. So now, yeah, here also just I will try to explain the high availability and disaster recovery separately. So here two things. Primary region means this is they both see. It's a very important question for a high availability. Okay, for a high availability, both primary node of the DB HANA node and secondary node will be on the same data center. Okay, but in a different network zones. Okay, see, you see here, follow me the diagram. Don't worry about any of these components. Okay, just follow what I'm trying to explain. High availability and disaster recovery in simple way I will explain. So you have a primary region, which means it is a Frankfurt data center. Okay, so in this one, okay, you have a production HANA. Come down. So here, check my mouse. Okay, production HANA primary, and then within the data center you have two zones. Availability zone 1A, availability zone B, which means both of them are in a different network. That is how they have configured, sorry. Okay, both of them are in a different network. So then your secondary node, you put it in the different zone within the same data center. Okay, so what happens? So from primary to your secondary node, always through HANA replication, your changes will move to the secondary, and secondary node will be available always. So if primary goes down, I mean, if due to network issue, then your secondary will pick up the application, but end users do not have any impact. Okay. So now, disaster recovery. In disaster recovery, the first thing is it's a disaster. So that's why you want to keep it in a secondary region or a different data center, if you ask me. So don't keep, if you have the primary high availability in the Frankfurt region, don't set your DR also in Frankfurt. I mean, because if there is a flood in Frankfurt, which means both the things are gone, it doesn't make any sense. I mean, it's not at all a disaster scenario. I mean, so you keep your another data center. I mean, you have your another data center at London, secondary region. Okay, that is why disaster. So there also, the concept is very similar, guys. So there you develop a production DR, HANA DB, another DB, third DB. So total you have three. One, production HANA, first one, where your business suite application is running live now. So in case of network issues, yes, it can pick the secondary HANA, the secondary node. So secondary node always in sync with the primary. Okay, and then you have a DR. So this is also in sync with the primary. Okay, now you can ask, hey, your production is in sync with the HA and production DR. Don't we cause some network bandwidth, network latencies here? So then see, this production is always up and running. Okay, and then you sync your secondary node with the production. That is more than sufficient. So you don't want DR to be synced with this production, right? You can take the same data from HA also, this secondary node. So that is why from the secondary node, asynchronously, I mean 1 or 2 minutes delay also, that is fine. Asynchronously, the data will be moved to the production DR, so that you can save, you don't hit the network too badly, because HANA changes too much of changes, right? So just to save the performance. Okay, that is also you can do. So this is how your HA and DR is achieved for your HANA database. So yeah, virtual and HubSpot topology. So this is in where Azure, I think this architecture, but let's not get into too much this one. So AWS example, network security architecture. Yes. Let's see again here. Just understand the basics. Don't get into too much of follow the diagrams. How network, so concepts are same in all three hyperscalers. Let me put the disclaimer. So I told you security is the one of the biggest concern for the customers in these cloud infrastructures. So now they have evolved and they are providing a very good security. I mean, especially in private clouds. So at least some customers in public cloud, they are not willing to go, but private cloud is secured. I mean, it is more or less similar to the existing on-premise data centers. Okay, that is why private cloud, when the moment they came up with this private cloud concept, that's it. Customers almost were willing to move. Yeah, many were willing to move. And as soon as SAP certified these infrastructures, then the customers were ready to take decisions also. I mean, they started moving.
Our comprehensive student metrics ensure top-notch learning experiences. We track engagement through attendance, participation, and video interactions. Performance is measured via quiz scores and assignment submissions. We monitor learning behaviors, including time spent and revisit patterns. Our metrics cover social learning, course completion rates, and even post-course success. With technical data on platform usage and device information, we optimize every aspect of your learning journey.
So, security. So you see right-hand side, there is a legend. Red color internet traffic, blue color intranet traffic. I mean, within the data center, like it's a LAN cable. Just blue color is a LAN cable, just think that. So green color inter VPC, security group, RT is the routing table. Okay. So don't get anything confused over here. So you have an internet. I mean, you did a www.google.com or thing. So it goes to the internet gateway first, wherever it has to go. I mean, it takes the IP and it goes there. Internet gateway will send it to the respective load balancer. I told you there is a load balancer. See, web application firewall, reverse policy, whatever. These are some network tools available over there. So the HTTP request says will come to the load balancer, and load balancer will send it to the ABAP or this thing. Okay. But here you see some terms like SG, security groups, right? SG. So which means if you know, I told you there is a VPN implemented for all the customers. Okay. So your application is accessible only when you connect to the VPN. So I told you VPN has the IP ranges also. See, in these security groups, okay, you will whitelist those IPs, which means you put your VPN IPs over here in security group. So which means if this HTTPS request comes from that VPN, I mean from that IP, then only your load balancer and everybody will. First of all, your internet gateway itself blocks it over there. So that is the very, very important, guys. So security groups are used to whitelist, that concept of whitelisting those IPs. Okay, that is how these guys will isolate the provide the security. Or if there is some abnormal traffic is coming, your internet AWS has a monitoring mechanism in the infrastructure. Okay, infrastructure mechanism. So they will block it in the entry level itself. They don't even let it to go to the load balancer also. So your load balancer is also safe. So this is how they provide the the security. Okay, via security groups or VPCs. VPC is nothing but virtual private cloud. Okay, so virtual private cloud is nothing but, so only if you are in that particular network, same. Once you connect to your VPN, then only you can log into your servers or the application, right? Same concept. If you are in that network, then only you will be able to access the server or the application. Okay, good. So, security design and monitoring considerations. What are the important security designs and monitoring considerations? Okay, security focus area. Number one, identity and access management. What is the identity and access management? User ID, passwords and stuff. And then intrusion detection and prevention. And if there is any abnormal thing is coming to the system, you should be able to identify. And then data security. and nobody should use your data. Okay, network and infrastructure security. Nobody should hack your network or the infrastructure. Security governance. What do you mean by the security governance? So each country has a definite set of rules. For example, Europe has a rule that all my companies' data should be in the European data center. Okay, they have a rule. So that is why European companies like SAP or any company you take, Benj, then whatever, Robert Bosch. So those companies, their data centers are within the Europe, and China also has a policy, right? China also same. China, even Europe, at least some lenient. You can keep in Belgium or Netherlands or somewhere, or Iceland. But in China, they have a policy, right? Everything should be in China only. I mean, that's why Alibaba, Huawei were the major players over there. For all China data, China applications, the data centers are within the China. So that is the rule. So that also these data centers have to follow. Okay. So this security, since we are talking about the security, see, we have SAP workload VPC here, Fiori or AWS AS. You see this diagram. So this is there. So I'll give you one example so that you will understand this concept. So what happens every time from the internet, a user connects to VPN, then only your this thing comes to your application and load balancer will take and this thing. So what happened once? One example I will give you where we were fine. So fine, I have a network load balancer. I have my SAP ABAP. So what happened is in the security group, one of our basis guy, so ideally we should be maintaining the VPN networks. So here two things. You can whitelist the IP and allow the traffic, or you can also stop the traffic by port. Okay. So one guy has opened one port. For SAP GUI, the port is 3200. Okay, 3200 is the port. So what you have to do, you have to open the port, only needed port. Don't open all the ports from 00 to 60,000. Don't open. Okay. So in this security group, we will maintain from the VPN connections. Okay. Once again, whatever the traffic comes on the port 3200, allow them only. And then HTTPS 443 is the port. Okay. So you go to your system and launch SMICM. You can see the port details 443. Okay. Only open only necessary ports, 2 ports. That's it. You are literally opening only 2 ports for the external world. That's it. So, and then you are maintaining the IP. So the guy who has built, and we have built only development system. Okay, here. What did this guy, basis guy? It's okay. I mean, some end user somewhere he has to access for testing purpose or whatever it is. So that guy doesn't have a VPN. So he's asking, we have to complete this testing in 2 days or something. What he did 3200 opened up for everybody, or 443 opened for everybody. Okay, you can give a star. IP you can give star, which means every traffic which comes to the port 443 or HTTPS request, if they address the right address to the system, they can come to the web server and log in. Okay, what happened? So this guy has opened it just for a time being. I mean, for 1 or 2 days. Somebody, so this happened in Google. I mean, there is no defaming them, but it happened in Google. It happened. So Google Cloud was the one which we are using. Hey, Baba, okay, you allowed the traffic. I mean, this guy, fine. Only one port he has allowed 3200, and moreover, it is a SAP GUI port, and it has nothing to do with the servers or anything. You can understand. So poor guy basis, he is fine, and it's not a basis guy fault. At times you have to open the port for everybody, because end users, if they're complaining about due to various reasons, just one port he opened and it has nothing to do. Only, and moreover, port opening doesn't mean that that guy can come and do anything, right? So 3200 will just allow SAP GUI access only. So then he has to punch in his user ID, password, right? Server details and all he has to give. So fine. So I mean, if he gives his user ID, password to somebody else, then he can log into the SAP. So there are multiple layers of security to come to the SAP system. So this guy has opened it. Sometimes we do it for everybody. What happened? So one particular guy, okay, he somehow hacked the server VPC. I mean, he was able to get into the data center, and he was also able to get into the availability zone of that particular data center and where our application is running, where our ABAP system or EH8 system is running. He was able to get into that location. Okay. obviously, SAP security mechanism, I told you, right? SNC. SAP, no matter any hyperscaler, that's why customers trust SAP so good. No matter whatever you come to the server or whatever you come to it, so they could not able to do anything in the system. I told you, even though you open 3200 port, he needs a user ID and password to log into SAP. And moreover, SAP servers are SNC, secure network communications enabled. So he could not able to touch or do anything on this server. That is pakka. That is SAP taken care. I mean, SAP took care. But what he did is he started consuming the resources. Okay. For example, he had come to my account. I mean, the virtual private cloud of this particular customer, and now what happened? He deployed. He was able to deploy more applications or consume the servers. Okay, and the RAM and CPU. For what he used? He used for data mining. Data mining. So it needs big data mining. So he needs that Bitcoin stuff. So he needs a lot of RAM and CPU. I mean, that guy has consumed around 2 TB of RAM, okay, and around 200 CPUs for 24 hours. Just imagine the billing it came to this customer. Billing. So because whoever used this particular VPC, right, that billing will come to the customer. Because it's your virtual private cloud. It's private cloud concept, right? I mean, they have dedicated particular zone to you. And if you deploy more servers and more resources over there, and it's a pay-per-use kind of concept, this cloud. That is how these pay-per-use means you use more resources, you pay for me that. So the billing has come for one day, 1 lakh euros. Okay, in the next 24 hours, we got 1 lakh euros of billing. We were shocked. Why? We were just using a small development system and we are testing it, and why 1 lakh billing came from the Google came 1 lakh billing. We were surprised and immediately we shut down that system. We shut down the system and we changed the password for this VP account, and then we immediately informed to the Google. Then Google identified that. Google did an RCA. They have identified that, okay, somebody had gone to the system and started using the because he was not able to do any of this, but he consumed the RAM, CPUs, and from the availability from the data center. He consumed it. So now who is the culprit here? So who has to pay that money? 1 lakh. So does the customer pay? Ideally speaking, yes, because it happened in the customer account. I mean, customer VPC, I mean, where it is a private cloud, customer is owning it. So Google says, hey, he has come to your system and you pay for it. So then we countered it. We countered Google and tell that, hey, first of all, when we are architecting, we have asked your security. Okay. I mean, see, if that guy come to my data center, number one, coming to the data center, who has to come? That is your responsibility. You should be taken care of. That is why security was the biggest concern earlier. So that guy entered the data center, you should have blocked at internet gateway. What are your monitoring tools for doing? What are your administration or the data center security was doing? Okay, you should have some monitoring tools or alerting mechanisms, right? So if somebody using such a heavy server, you should have get an alert. Were you sleeping or what were you doing at the time? Now you are saying that he came to my server. Yes, he came to my server, but he could not able to do my server. Luckily, we protected it. What if it is a production system? What if it is a production system and if he was able to get into the system? It could have led to so much of this thing, thing. Then we went back and put Google in a very tough mode. There were almost some 2-3 hours of heated discussions with Google, but we SAP guys, who were working on that project were very strong, and then we put our case strongly. In the sense, we are not going to pay you this money, 1 lakh euros. 1 lakh euros is not 80 lakh rupees, man. For 24 hours, who will pay? It's too much money. So we said, and then if it is that, then our company will ask us, why you guys opened that? Then we put it to the Google. First of all, tell me what your tools were doing. And when we put that question back to them, then they were like, okay, no, sorry. And then let's do one thing. We will share this money. Okay, share this money. 1 lakh euros is the fine. So Google said 50,000, I will take the share. 50,000, you take the share. That also we did not agree. I mean, the remaining 50 also we don't pay. It's not our responsibility. Then what they did, they gave it as a coupon, or they don't return the money always. So they just give a gift hamper or something so that we can consume few more resources. Yeah. So this is the kind of security I'm talking, guys. It's very, very important. That is why you see this architecture. You may feel it like, why the hell they are putting these many things, components, internet gateway, and then there is a VPC, and then the traffic comes from there to network load balancer, then network load balancer to the SAP system. And in the SAP system itself, I told you SNC is there. So there are a lot of security, guys. Security is the most important thing, okay, for the banking and all. That is why they have these many layers. So, and this is the biggest concern, and this is one of the topmost, okay. And then you also have the GDPR guidelines. So that is the security governance. I mean, GDPR means Europe has some guidelines where you can't put your email address, or where you can't give the mobile numbers of the, system should not track those details. I mean, when you're creating purchase order or anything, that data should not be put it in a table or something. It has to be encrypted. Okay, such things. Good. So intrusion detection protection. This is what I mean when I'm talking about the virus, malware, DDoS protection. So that is what HTTP. People keep dumping the data to the server until it crashes. You may ask why they are doing it. It's just for the fun. People will be there. So DDoS attack is that. So that is why HTTP is not secure. So until the server crashes, they will use the DDoS. They keep tracking something. So in the idea of getting something out of the server. So infrastructure hardening, vulnerability scanning. So there are so many things you have to do. The data center or the cloud provider has to provide you these things. So these are all things, data security, encryption, and so on, so stuff. Okay. So network infrastructure security, SSL certificate management at the bottom, security patch management. So again, load balancer, external. These are the components. For now, you just know it. There are components like that in that architecture. This is the information about them. But for now, you don't need to get into this too much of these things. Okay. And then monitoring responsibility. Yeah, monitoring responsibility. We will discuss this and we will close this one. Okay. As I given in the example, monitoring responsibility. That guy came and he consumed the servers. He consumed the high resources and the billing came to the customer for us. So who has to take care of this? Hyperscaler global infrastructure, hypervisor, or these guys. Hypervisor in the means Google or AWS should take care of the infrastructure security. Whom you are allowing and whom you are not allowing, it's your headache. Because you have given me a simple private cloud over there, but if you put it on a public cloud, a lot of guys are coming into your cloud. So it is yours. You should have a monitoring mechanism or alerting mechanism when there is some abnormal or attack has happened on the data center. So in our case, we were clearly able to establish that they were not able to do anything on our SAP system, but it is a case of guy who entered into the data center, and we fired them back stating that you promised us that nobody will access this data center, but how come a new guy came into this data center? That was our first question. So then Google took a back step and then reimbursement mode they came. So the hyperscaler security. So it looks so easy, guys, but security is one of the highest top critical component when it comes to the ERP systems, okay, business data systems, infrastructure, operating system. So infrastructure services, OS, SUSE Linux or anything, backup and recovery, networking and security, monitoring. So managed by customer or the partner. So these are the things. SUSE Linux. Suppose if you give a root access to somebody else and your server details to somebody else, then you cannot go and tell your hyperscaler, right? You cannot go and blame Azure or Google. So if a guy get into the system and take a backup and this stuff, which means there is a compromise on the data, SAP level or the application level. So it could be customer or partner. What is it mean by customer or partner? Suppose if your customer is Unilever, so it could be by TCS or by Unilever itself, they take care of it. So infrastructure and services, applications. So SAP operation services, basis administration, installation, upgrade. Again, this also either Unilever can have their own basis guys, or they can take support from TCS or SAP or IBM or anybody. So this has to be very clear. So in any of these top two layers, if there is a compromise, if you give an SAP all access, I gave one example, right? Where then BP, they were fired entire team. If you give an SAP all access, whose problem is it? It's the basis, operation, whoever is supporting this. If somebody gave root access, it's an OS problem. If somebody, like a Google example, That is important. If somebody get into the servers and consumed your account, which is infrastructure's problem. Okay, so that is why these are very, very important. So there are a lot of slides after this. So we have reached to the 45 slides. This is more than sufficient for you to get a fair understanding of the hyperscalers. Okay, so far. So, and then you have a lot of slides where we are talking about these advantages, compute pricings, runtime considerations. These are all, for now, they are not important for you. So this slide we will discuss personas. These are all, leave it. They're not so important. It's like N+1 architecture. You can deploy another server and build these systems. It's not so good, just for your information. IT architect. So personas means, what are the, suppose I told you. So this slide we just discussed. So hyperscalers infrastructure, operating system is us, and then database application supported by the basis. Let's keep this as, customer or the partner. So now, what are the people who will be doing what? Okay, this is important. So you see, I told you this cloud infrastructure also, it comes to mainly the 3 people, and the basis guy will be there. You don't see any name of server architect or server manager. There are different names for them. You don't find AWS functional, no. So when you are moving or migrating a system from one data center to another data center or moving, so basis guy definitely needed. There's no doubt about it. So IT architect. So this guy will be taking care of the entire planning. I told you, running that mock report submission, that guy will be there. So, okay, he will be ensuring the entire, this high availability, disaster recovery, the whole design, he will take care of it. And then cloud architect. So what he will do? Cloud architect, he will take care of the hyperscaler, infrastructure only. Okay, providing infrastructure security, those VPCs, networks. Okay, that will be taken care by the cloud architect. Basis administrator, deploying the basis, which we are. Roles and responsibilities, we all know. Okay, deploying, migrating the system, installing or upgrading, and then ensuring the right security groups, creating the users and users. So that is the basis admin role. The security, again, you don't need a security guy. This is a part of, this is also expert understanding the identity management solutions. The security solutions. Expert in understanding the VPN. I told you, virtual private network. So network, like you are using login, right? So what IPs, what are the ranges of IPs they have to provide and stuff they need to understand. Okay, VPN. So network architect. So this guy is only meant to safeguard the network. Okay, in that particular data center. So what traffic is coming, setting up the firewalls. Okay, setting up the monitoring tools. If there is any too much traffic is coming from one particular IP, so you can quickly log in and you can check what traffic it is. Okay, and then administrator. So expert, this is more or less one of these guys will do. Administrator, nothing but is like kind of hyperscaler pricing and provisioning. So it's just a relationship with the hyperscaler team. Okay, so this is what is the hyperscaler guys.